Hello everyone. I hope you are doing well. Oh, sorry for the interruption. That last in the I uploaded the solution, but actually I forgot to turn on the headphone, so the voice was not clear. So I'm reshooting the video. So don't worry about that. If you watch that quickly, you can cover this video. Okay. So this problem is implement router problem. What does this problem say? That design a data structure that can efficiently manage data packets in the network router. So this is a very interesting problem, I would say, about that. Very interesting. We'll see the entire intuition that how we can approach this problem and how can we think about that. And if you're new to the channel, make sure you do the subscribe button because subscribe is important, and make sure you to like the video because we make awesome content around DSA tech and around that. So stay tuned for the more videos, right? So this is an interesting question. It's a computer network question. It says that you have a source, you have a destination, you have a timestamp. Okay. So you have a packet that has a source associated with that destination and a timestamp. Okay. So what you need to do, you need to implement that router class that initialize the router object with a fixed memory limit. Okay. Like there's a memory limit associated with that router. Then what you have to do, that you have, if you're adding a new packet and if you exceeds the capacity, the oldest packet would be removed from the free up space. What that means is, let's say you have packet p1 and p2, then p3. They come in this order, like firstly p1 comes, then p2 comes, then p3 comes. And let's say your size is only 3, and another packet p4 comes into the picture. Then you have to discard p1. Why? Because p1 is the oldest packet, right? So that's the why saying that exceed the limit, the oldest packet must be removed to free up the space. Okay, fine. Then what did say that? Okay, bool add product or packet, sorry, not product. What they are saying is, okay, let's say they're P1 only and you have to add one more packet. So you have to add like this P2. Why? Let's see. It says that a packet given to the attribute, a packet is contain a duplicate. Okay, there are too many things associated with that. Firstly, we have to check that the new packet, whatever you have added, is it same with any other packet in our structure where we are storing all the packets. So we need to check the duplicacy as well. So we will check firstly the duplicacy. If the duplicacy is there, we just straight away return false. Okay. So which data structure would you think would be most appropriate for that? For checking the duplicates, I think you guessed that right. This is the set data structure. You can use map as well as per your wish, but I will be using the set data structure, which will contain the complete three tuple side of time, right? Source, destination, and timestamp. Fine. And then what are you gonna do? It's very simple. Then it says that, and if it is not available already, then insert it. Okay, that makes sense. Then what we have to do? Then we have to forward the packet. Forward the packet means whatever packet that comes in the chronological order, means first in first out order, we have to return that first. Let's say P1, P2, P3 came, and then you want to return the packet, forward the packet, you have to forward this first, then this, and this is the first packet will be forwarded, this is second, this is third. This is how they have entered. It's a, like a queue system. And from this you should get a hint, right, that what they're trying to specify. So if you, in a way, if you understand that both the operation, the above operation also, when you are deleting, when your memory limit is exceeding, you're deleting the first element from the front. And same when you're forwarding the packet, then you're deleting from here itself. It's clearly indicating you should clearly use a queue for storing the packets. And that's how in real life also works, right? Storing the packets. Okay, that is fine, that you have did that. And now most interesting and the most difficult part of this problem is this get count function, right? How to implement this get count function is the most difficult bit. Now if you think like that, uh, the problem with this approach is that we don't know that how to calculate the number of packets within a given timestamp, right? That we have a timestamp, and then we need to check that for a particular destination. Let's say we have a destination, let's say this is 5, and there's some packets associated with destination 5, and they have some timestamp, let's say T1, T2, and some timestamps are there. Then what we need to check, the number of packets that are currently there in our system. Okay, they're not been yet forwarded, that means they're not popped out or they're not deleted yet. They have specific destination of timestamp in the inclusive range of start to end time that we need to deliver. So firstly, let's try to quickly go through and implement this add packet function and the forward packet function. Then we will come to this get count function. This is a separate thing we can solve separately, then we'll quickly solve the add count and add packet function and the forward packet. So what we'll do in add packet thing? So it's pretty simple, right? What are you gonna do? You'll check first, check whether the packet, whether it is already present or not. It is already present or not. Right? If it is already present, what are you gonna do? You just return a false. Right? Already present. If not, then you will insert it. Else, insert it. Fine. We'll insert it. And I already specified that since it already give you in a hint that you have to use a queue. Why? Because the first in first order, you have to forward the packet. Then the first packet should be uh, popped out. Right? It is happening like this. The packet are coming in this order: P1, then P2, then P3, then P4. You're pushing from here, inserting from here, and popping from here. So that's how a queue works, right? That's how a queue works. That's why we have to that do that. Fine. That makes sense. That makes sense. Then what we have to do? Add packet we have done. Then what you have to do? Else you just directly insert it. Insert, you can directly push it. Now there could be two scenarios in the pushing as well. What could be the two scenarios? It would be like the size limit has been reached. Size has been limit. If limit not reached, then no problem. You can directly insert it. Limit reached, no problem. If the limit is reached, what do you have to do? Think about it. What they told in the problem that remove the oldest message, which is same as remove the oldest message, is a fancy name of the front element of the queue, right? Oldest packet, same as front of queue. Why? Because this is the oldest, right? This came very early. Very early it came. That's why you have to remove that. So I hope you understood the add packet logic. There are two, three if conditions you have to handle. Then quickly let's try to come up with the forward packet thing, forward thing. So what do you wanna do? Now you have to do two things. Again, there are two conditions that let's say your q dot size is empty, equals to 0. That means you have no packets itself. All packets are forwarded. So you have to return a empty array. Elsewise, what you need to do? Again, you have to forward the front pocket, front packet. So take out, take out the front element. Right? Take out the front element, and that's all. That's all, right? That's and then you have to what you have to do? Just take out the front element and just return this element. Okay, this makes sense. This makes sense, right? Just return this element because this we want to forward. So I think the forward and the add packet you must have implemented that, and you have thought about it that okay, I can use a set and I can use a queue system for these two functions. But the most interesting part of this problem is get count function. Let's try to discuss what kind of data structure we can use to solve this problem. Now we have to implement this get count function. Okay. Now the interesting idea about this problem is uh, what you have to do. You have to efficiently do it. That we have to calculate a particular range how many packets are there, right, for a particular destination. So the one idea many people have thought about it must be, oh, it's not a problem. Create a map of integer for a particular destination and create all the sets, all the sets for the packets that right a particular destination, let's say 5, it could be timestamp, let's say 100, and it have 110 and 115. Also remember that the packets are coming in the increasing order of timestamp. That's also very very important. That will help us to solve this problem very quickly and efficiently as well. Okay, then you will say that why you use map. You will be like, I have used the map because bhaiya, it's very important. We have to delete some packets as well. You have to delete the packet as well. Packet as well. So we need to have a set kind of thing where we can delete the thing efficiently. and then we have created that. But the most important problem with this is you cannot calculate indexes here. Why? Like you cannot calculate, let's say I give you a set, I give you a number, let's say X, and can you tell me, think about it, can you tell me how many elements are larger than X? Efficiently, obviously. Like, O of n solution you can give V anyways. But if you think about it, this is a O of n thing. Cannot do in. You think, you try to think and sit back and relax and try to think about it. Cannot be done of log n. Think about that. You cannot do that. That's a interesting part of this problem. You will be like, okay, no problem. This is fine. I understood you what you are trying to say. That I cannot do that. Then you will be like, but you have to delete elements also. So you cannot use something like this also. Now the other option might be you will be like, I will be use this. Then what is the problem with this vector? Timestamps are also in increasing order. So this is also be sorted. I need not to sort is also an interesting point about this as well. That I can calculate the number of element which is larger than a particular x. Why? Using the lower bound. Same problem I can solve lower bound plus the indexing thing because index available is there, right? In arrays, there are index available. So if you can do that using this lower bound or upper bound, whatever you want to do, and you will be like, because let's say I want to tell you how many elements are greater than x. So let's say your array looks like this, and I want to ask how many elements are greater than 3. So what you gonna do? You're gonna find the index which is least upper bound that 3, and then you will find the index as 0, and then what you want to do? N minus the index, which is 3 elements, right? This is how you can do it, but there is no indexing in set. That's why you cannot do in a particular set. So you're absolutely right, but what is the problem drawback here? Drawback here is you cannot delete elements efficiently. You cannot delete elements efficiently. That's a drawback. So you will be like, we are stuck. One thing is good here, one thing is good there, but what to use now? We have to do something. Now, I will tell you a very interesting approach that will blow your mind. Oh, we can do like this as well. Right. Idea is, let's say to see how elements are being deleted. If we approach, see, anyhow, we have to get the ranges, right? So we have to modify in this second approach because first approach won't gonna work because there is there's no way I can get the range efficiently. Here there is some way, but can I optimize this deleting part? Now the question arises, do I actually need to delete? Do I actually need to delete? That's my question to you. Why we are deleting? Problem is some packets are being forwarded, some packets are being deleted due to the memory issues that right many packets are coming. So you will be like, yeah, we have to delete it. But do we delete in this map or do we do something else? You will be like, what is the bare minimum requirement I need to know about a particular destination number of packets? Let's say I have this 510. This is the destination and this is the packet timestamps 102 and so on. Okay. And then I need to tell you that okay, how many packets are greater than 10 or maybe equals to greater than equals to 1. You will be like, okay, okay, okay. This I can tell from here. Answer would be 3. This is fine. But how do I tell that I have this kind of thing? I have a vector which is like 100, 101, 102, and 103. But you are not sure that how many of them are packets are deleted. Either to you change every time this vector that okay, whenever some packets are deleted, you are delete from there also. But if you observe one important thing, how these elements are deleted, that's very, very important. That see, it's a first in, first out thing, right? So whatever come first will be deleted first. So If 100 has been, if 102 has been deleted, then these two must have been deleted, then only 102 can be deleted. That's very, very important condition. Why? Because the packets are coming in an increasing timestamp order. So you can definitely say that there's some packets here which are deleted. Let's say them X, and then some are remaining. Some are remaining. And I'm not changing that. I'm not changing that. I am somehow, I have to maintain this X count, that how many are deleted. Did you get some intuition? Oh, this is interesting. This is becoming interesting. Means for a particular destination, for a particular destination, if I somehow know this X, somehow I calculate this X, then my job is done. Then my job is done, right? I don't need to do anything. I just need to search. I don't need to search in the entire array now. I need to search in this part only. And I can apply the lower bound binary search, whatever you want to do. It's your wish. Lower bound is a very better way. So you will be like, okay, how would we maintain that X? They are pretty simple. Think about it. Think about it. Again, use a map. And what you gonna do? It's gonna be calculating that how many times you have deleted that MP for a particular destination, how many times it is being deleted, that particular packet for that destination. Okay, you will be like, oh, we can do that, and we can get the X for that particular destination, and then we can search that. So I hope you get the entire intuition that what we are thinking in mind. I will show you the code. If you did understand the entire logic, we'll see in the code how we implemented that, and you'll understood it properly. And if you understood it till now, then only, then make sure to like the video and subscribe to the channel. So quickly, let's go through the example part as well. So it's a add packet. So packet is been added 1490. Okay. And router is there. Router initializes size 3. Okay. Size 3 has been initialized. Fine. Then it says 2590. We'll push 2590. No problem. Then it says 1490. Oh, it's already available. So I have to discard this packet. I have discarded that. Then it's 3595. I will add that. 3595. Then it says 45105. Now my size is only 3 only, right? So I have to discard this. That topmost. Why? It's pushed earliest. So I will push 105. Then it says me forward packet. Forward packet I already told you, which is the this one topmost. It's forwarded this one. Then it says that add packet. What is the packet has been added? 52101. So this 52110. And then it says that get count. Get count means 110. Basically, we have to tell 100 to 110, and this is the destination. The destination is there 5, and then I have to tell for 100 to 109. This is the packet. Only this is the packet, which is the destination node. This is becoming one, right? I hope you understood the example. And then let's try to quickly go through the solution of the code, that how we implemented entirely. So what we have did is we have maintained a limit, which is initialize our memory limit. I initialize the packet array, which will tell me that how many duplicates I can tell or not. And then it is there is a map which will store my whole mapping. This for a particular destination, how many, what you can say, the packets are available, the timestamps are available, right? And this will tell me for a particular destination how many packets are being deleted. Okay. You okay? Okay. Okay. I am getting a hint. I'm start getting a hint. I can think of. You can pause. Try to solve it. Come back if you are not able to do that. Okay. Then I will. What I will do? I will introduce a queue. What will this queue do? You will queue the store the packets in a first order, first in first out manner. And then what I gonna do? Limit initialize with memory limit. Fine. What I gonna do in add packet? I will check the duplicacy. Check duplicate. First step. Right. If it is duplicate, I don't need to do anything. Just return false. Fine. The next step is check the size is greater than 0 or not. If it is greater than 0, and let's try to check the limit has been reached or not. You can skip that operation as well. But okay, you have to check this thing. The limit has been reached. That means I cannot insert one more element. So what I do, I need to pop out first the previous oldest element. This is the oldest element removal. Oldest packet removal. This we remove erase from the packets array as well, because this is our set containing, right? And also now we have removed that. Now we have our destination will become plus plus, right? This I remove one bracket from the destination, that will make the maintain the counter, right? That's what you want to do, because I'm not removing from my PD array packets to destination array. No, 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 no need to do that. We will contain all the information, and this we will do to increase our X. That's very important. Fine. And then what we do, we just push the element, we just push this timestamp into our destination node. And then what are you gonna do? We just insert in the packets array as well. We're pushing in the queue array, in the packets, and our end destination. Three things we are pushing, and then we're returning true, because yes, we can insert that. Fine, no problem. Then how do you forward the packets? We'll check, are there any packets available? So yes, they are available. Then what are you gonna do? Oh, pop out the front element. I already explained you. You're forwarding the packet from the front side. And then what I gonna do again? Packet dot erase and remove again. You're removing the packet, removing the packet to remove the destination. Increases plus plus P1 corresponding to destination, by the way, destination. And then they were gonna pop, and then we just return the whatever vector of the source, destination, and timestamp. Fine. Now the get count becomes interesting. Now you have everything sort of. So firstly, we'll check that whether the destination have some timestamps or not. Then only we're gonna check, right? There's no destination, there's no packets corresponding to that destination. Then you don't need to search anything. Just return zero out of it. Okay, that's fine. Other than that, I have calculated that X, that how many packets I have deleted for that particular destination. We did that. And then what we're gonna do? We're gonna do auto IT equals to lower bound. This is very important that we search. I already explained to you right here that we are searching for this. We are finding this X that we have. Reducing my search space. I'm not searching in the entire array. I'm searching only in a certain range, which is X to N. Only this array. That's very important. How does it helps? Let's say I want to search here. Let's say I want to search how many packets are greater than 100. But my X is 3. So what you gonna do? You will search from at least from here itself, not more than that. Like, I am assuming one base index, but I'm just giving you an idea that you just need to search from here. You don't need to calculate these. These also greater than equals to 100. You don't need to calculate that. That's why we are just searching from here. Plus X destination dot end start time and end time. And what we are doing essentially, since we have to do the inclusive thing, start time and end time. So what we gonna do is we gonna go ahead for per bound for end time. The last thing which is not being included, it will be like, okay, it will give an index which is not being included, let's say 4, and lower bound it will be the smallest thing that it will be included, let's say 2. So what we will do, we'll just do 4 minus 2. We don't need to do a plus 1 because 4 is not included, so it's like this. So I hope you understood the entire intuition and the thought process. The code part, it's a very interesting problem, very practical problem, and it could be solved in many ways. But this is one thing that I found it very easy to implement and easy to understand as well, the entire thought process. So if you like the video, do make sure to the like the video, subscribe to the channel, and we'll make more such content around that. Okay, see you then.